my dad's slide rule. I'm not exactly sure who owned it, but it says gift from RLM, Richard L. Morrison, 1956. I'm not sure from him to somebody, but it's his slide rule. At least I had it, so I don't know. Anyway, it's this pocket model. It's like 5 inches long. If you watch the movie Apollo 13, they use one to do their calculations, and I was always wondering about the calculations. It's a Model 300, square roots, tangent, sine, multiplication, division, log. Let's just talk about multiplication, division first. So what you do is you take it, and let's say you want to do something simple like 2 times 3. It's not very exciting with the multiplication, but 2 times 3. So what you do is you take the hairline. It's hard to move with one hand, so take the hairline thing, and you're going to move it to, we're using C and D, so we're going to put the hairline on 2, like that. And then we move the index, so this middle thing moves. I'll probably end up moving it because of whatever. So then the middle thing moves, and you put the index. Oh, I need 2 hands. Yep, hold on. So the middle thing, you move the index. Keep going. I can do it now. Okay, good. To there. And so that's the index. So now it's where we started. We're starting on 2, and this center one should be lined up exactly with the hairline. And now we're actually move the hairline. We're not going to move the middle thing. So 2 times 3 is 6, right? So I'm going to move this to 3 on the center one. And if I move it to 3 on the center one, whoopee, we get 2 times 3. The 6, the answer's on the bottom. That's not too exciting. Let's do sine and cosine. So on sine and cosine, let's say I have this information right here, and I'm actually looking for B. And let's say, no, in this case, I'm looking for the angle B, not the value B. It's a 3, 4, 5 triangle, so maybe you already know the answer, but I'm gonna give the value B, which is the angle B right here. It turns out to be 37. That's the answer. But the cosine of the angle B is equal to adjacent over hypotenuse. So adjacent is 4, hypotenuse is 5. Let's find that angle. So you solve it by proportion, I guess they would say. And so I'm just going to write it like this. Cosine B is 1 over 5. So sine and cosine, so the letters on here, what did letters represent? The letters represent A and B. Apparently they're first squares and square roots. T is tangent, S is sine, and C and D we just showed you were multiplication, division. And then we have the log scales. But we're going to deal best right now with sine, and we're going to go all the way over here. And we're going to start with the sine being, and by the way, I got that this information for this part off of a cool little teaching thing, cosine on slide rules in mathematics. Anyway, so what you do is you start off with the 5, and you put the hairline on the 5, which is right there. And then you, second step is usually to put the index over the hairline. So if I can move the middle part, which is the hard part, with one hand. So I'm going to slide this to the index, and you can see the index is just the end where all those lines line up right there. All the lines line up. So now it's over the 5 in the index. And then, so Then we're going to throw in the 4. And so the way you get to the 4, so we got the 5 on the bottom. We've got an index. Now that we get to the 4 is you just slide the hairline over to the 4. And there's the 4 there. And, okay. Now the interesting thing is the sine and cosine. It says sine, but the opposite number is cosine. That's on the left. And so there's a little rule, and basically it's the sine and cosine are related to each other within 90 degrees minus the angle. And so if you look at all these numbers, these very small numbers, we got 60 and 30 is 90, and 50 and 40 is 90, right? And then over there we got 75 and 15 is 90. So all those relationships, on the left side is the cosine, and the right side is the sine of the angle. And so this one, it's really hard to see, but because the scale is so small, this is pocket size. Like I said, they took it on the Apollo mission. So that's 20, 30, 35, 36, 37. And so right where the hairline is, right, we go 20, 30, 35, 36, 37. Right where the hairline is, 37. And if you know anything about sine and cosine of a 3, 4, 5 triangle, that angle is 37. So pretty cool. Maybe I'll do one last one. And so this final one has to do with using tangent. And this is what you get. Okay, and this one I got from Easy Slider. And just an example of my own slide rule. Okay, so in this one, we're gonna actually first move the hairline to 50 on the tangent scale, which isn't very far. It's a short trip to 50 on the tangent scale, which is right there. Then we're going to move the index. That's pretty much always the second thing you do. So I'm going to move the middle, which is always hard to move with one hand. So that means we're going to move to the index on the hairline, which I'm going to scoot right there, the index. And then finally, we're going to move the hairline to 6. And you can already see where it's going to land. And if you move the hairline to 6, and I moved it around a little bit because the right answer is actually a 5.03 from the calculator. And from the slide rule, if you do it very carefully, you'll see that it's slightly north of 5. And I actually did move it a little bit because I'm doing this with one hand. And it really ended up last time, if I move it over a little bit, nope, it ended up like right there. Which, golly, that's so close to the correct answer on the calculator. Anyways, pretty interesting how the slide rule works. I can imagine that, I don't know, with some of the other scales it might have been hard to learn how to use. But I think with the sine and cosine and that kind of stuff, it probably was pretty darn useful before you had the calculator. So this is, like I said, 1956, and you really didn't have these calculators. This is from probably like 1986. But 1956, that's a pretty cool thing. Maybe I'll start using that instead of a calculator. It's more fun. Pretty cool. Thanks, Dad.